This is Chemistry, Unit 6, Chemical Composition. How do we use molar mass? Mole to mass conversions. The molar mass of an element or compound can be used to convert the mass of a substance into moles or the moles of a substance into mass. So let's take a look at some examples here. So example 3, how many grams of iron are present in 1.78 moles of iron? So here's some iron, okay? So if you know that 1 mole is this many grams, right? This 55.84 grams in the periodic table. How many grams would be in 1.78 moles? So this is slightly larger than a mole, so it should be slightly larger than what you're seeing on the periodic table. But you need to show this. I need to see how you're actually figuring this out. So you set up your t-square. You're provided with 1.78 moles of iron. And you know this, right? In the periodic table, this is our conversion factor. In 1 mole, you have 55.85 grams of iron, which is what I looked up right here. But why is the 1 mole on the bottom and the grams on the top of this t-square? Because you're trying to eliminate moles and solve for gram. So the moles will cancel, and you'll be left with gram. Now to solve this, you take 1.78 times 55.85 grams. And if you want to, you can divide by 1, but you'll still come out with the same answer. But you're free to do so. There's nothing wrong with that. And the answer is 99.4 grams of iron. Now, why did I round it in this manner? To match my significant figures of what was provided in the problem. 1.78 has 3 significant figures, and so does 99.4. All right, how about example 4? How many moles of calcium are present in 5.78 grams of calcium? So here's some calcium. So now you have a small amount of calcium, and I'd like to know how many moles that is. So this is actually less than that molar mass on the periodic table, so my answer should be less than 1 mole. But let's prove it. You're going to start with 5.78 grams of calcium, and if you look up calcium on the periodic table, it's 40.078 grams. And we know that that's comparable to 1 mole. That's conversion factor. So you're going to put your 40.08 grams on the bottom of this t-square so that it cancels with the grams of calcium that you started with, and you're left with mole. Now how to solve this? You will take 5.78 times it by 1 and then divide by 40.08. And now your answer, rounded, will be 0.144 moles of calcium, which is significantly less than 1 mole because we had significantly less than the mass we see on the periodic table. And I rounded in this manner to match my significant figures of what I started with. So 5.78, 3 significant figures, 0.144, 3 significant figures. All right, example 5. How many moles are in 6.59 grams of nickel? So you're starting with a small amount of nickel, which is actually less than the mass you see on the periodic table. So we should have less than a mole for our answer. But let's prove it. 6.59 grams of nickel is our starting point. Now if you look up nickel on the periodic table, it says 58.693. I will leave that as 58.69 grams of nickel. And it's comparable to 1 mole. So there's that same conversion factor. The grams are on the bottom so that they cancel, and you're left with mole. Now to solve this problem, you take 6.59 times 1, and you divide it by 58.69. Now my answer, with proper significant figures, it should have 3 to match the 6.59 that I started with, is 0.112 moles of nickel. Now remember, we started with quite amount less than what you see on the periodic table, right? 6.59 compared to that 58 on the periodic table. So if that 58 is equal to a mole, if I have a lot less than 58, I'm going to have a lot less than 1 mole for my answer. So I know that this is right. All right, for example 6 now, look at the question. It says, how many moles are in 92.2 grams of iron 2 oxide? So you now have a compound. So this is going to involve several steps before you can actually solve the problem here. So the first thing you need is that formula. So iron is Fe. That Roman numeral 2 means it's a +2 charge. Oxide is coming from oxygen, and that has a -2 charge. So they look like this. And then if you cross these, you can see that the charges cancel out, and this is FeO. So this is the compound now that I'm working with. All right, the next thing we need now is the molar masses of each of these added together. So I just go left to right. If you look at iron, Fe, 55.845, I'll round that to 55.85. And then oxygen is 16, right? 15.999, we like to round that to 16. This is not oxygen by itself, it is part of this compound. So you use however many oxygens are in the formula. And here we have just one. Now if you add that together, you get 71.85, and this should be gram per mole. So that's our molar mass. All right, now we need this to answer the question. You have 92.2 grams of this, and I'd like to know how many moles is that. So you set it up now the way you've been watching me set up these problems now. So 92.2 grams of iron 2 oxide is my starting point. That's what was provided in the problem. We now know the molar mass. We calculated it ourselves. 71.85 grams of iron 2 oxide is comparable to 1 mole. The grams is put on the bottom so that you can cancel out the grams that you're starting with. And then the 1 mole is on the top. Now to solve this, 92.2 times 1 divided by 71.85. Now my answer is 1.28 moles of iron 2 oxide. So why do I have 1.28? Why did I round it this way? To match the significant figures of what I started with. And again, you can tell if your answer makes sense. The molar mass of iron 2 oxide is 71.85 grams. That's how much you have in 1 mole. So if you have 92.2 grams, you have more than that molar mass, so you should have more than 1 mole, and you do. All right, last example here, example 7. How many grams are in 3.84 moles of nitrogen dioxide? So here you have the formula, but this is a compound, so you're going to have to find the molar mass of this compound and not just an individual element. So you just look it up. Nitrogen, 14.007, I'll round that to 14.01. Now oxygen, 15.999, we like to round that to 16. Now this is not 2 because it's diatomic, it's 2 because there's 2 in the formula, right? As part of this compound, so if there's 2 in the formula, then you have to multiply oxygen by 2. So 16 times 2 is 32. And then together, you have 46.01. This is actually gram per mole. That's the molar mass. Okay, now you can answer the question. You have 3.84 moles of nitrogen dioxide. So if you know that there's 46.01 grams in 1 mole, how many would you have in 3.84 moles? So your starting point is what you were provided with, 3.84 moles of nitrogen dioxide. Now you calculated 46.01 grams per mole. So if you're starting with mole, you want that 1 mole on the bottom so that it can cancel with the moles you started with, and then that gram value on the top, 46.01 grams. So the moles will cancel, and to solve the problem, you take 3.84 times 46.01, and if you'd like to divide by 1, you can, but it's actually not necessary. And your answer with correct significant figures is 177 grams of nitrogen dioxide. So there's 3 significant figures in my answer to match the 3 that I started with. Now, does your answer actually make sense? Yeah. 46.01 grams is how much you have in 1 mole. So if you have 3.84 moles, you should have more than triple the amount of grams, right? And you do.